let's see. Okay, so section 2, right? We're going to talk about some logarithms. So take a look here. Just quickly, brief overview, all right? So look, these are the powers of 2. Powers of a number means that number raised to different exponents. So the powers of 2 are 2 to the 1, 2. 2 to the 2, 4. You guys know this. 2 to the 3, 8, right? But what happens when I went from an exponent of 2 to an exponent of 3, the power jumped from 4 to 8. I skipped over all these numbers, 5, 6, 7, 8. Well, what if I wanted an exponent of 2 that would give me a 6? Well, when I went from 2 to 3, I completely skipped over that, right? So how am I going to find out an exponent of 2 that would give me a 6, right? Like an exponent of 2 that would give me an 8 is what? 3. But what's an exponent of 2 that would give me a 6? Well, that is the question we're going to try to answer today. Okay? So that's basically what we're trying to figure out. 2 to the what equals 6. To answer the question, what we need is a logarithm. So the logarithm answers the question of what exponent of a given base will result in a specific value. Meaning, a logarithm, right, is just a what? An exponent. So let's say that together. What is a logarithm?
An exponent.
Right. One more time. What is a logarithm? An exponent. So if I'm walking down the street and someone taps me on the shoulder and says, hey, I'm sorry to bother you, but what's a logarithm? It's an exponent. Okay? That's what it is. It's an exponent. So let's explore some logarithms. Look at this. This is a power. This is something that you're used to seeing over and over again, right? 3 to the power of 2 is equal to 9. Nothing mysterious. We know this. We know that this 3 is called a base. That's the exponent. Okay? Now, I can rewrite this a different way. Because a logarithm is an exponent, I can rewrite it like this. Log base 3 of 9 is equal to 2. So do you see how this base here becomes that base over there? And this exponent here becomes the answer to the logarithm over there. Because what is a logarithm? Just an exponent. It's nothing mysterious. It's just an exponent. So 2 to the 5, 2 times 2 times 2 times 2 times 2 is 32. In here, where is the base? It's this 2, correct? So when I put it in logarithm form, it's log base b 2 of 32. And where is the exponent? That's the answer. Okay? So this is the base, and the answer is always the exponent. So 4 squared is how much? 16. In this setup here, there is a base of 4. So I can rewrite that as log base 4, right, of 16 is equal to the exponent 2. Okay? So, here, right? Okay. We have log base 3 of 27 is equal to 3. So take a look at this 3 here. What is that? What does that represent? A what? The exponent. Every exponent needs a base. Where is the base? The other 3. Okay? The other 3. So remember, it's log base b, right? So every exponent needs a base, and it's this one. So the way I can rewrite this is 3 to the power of 3 is 27. Okay? So, if I were walking down the street and I saw a billboard that said this, going back to this, log base 2 of 6, if I just saw that on a blank billboard, I would tell myself, oh my God, someone's looking for an exponent of 2 that would get them a 6, right? That's all a logarithm is. So taking that with us, let's explore. If we are talking about exponents, then there are some special things that happen when we are dealing with ones and zeros as bases and exponents, right? So let's remember, any number raised to the power of 1 is what? So it's the same number. And any number raised to a power of 0 is 1. So what's 2 to the 0? 1. And if I were to write that as a logarithm, this is the base and 0 is the exponent, right? Base, exponent. If I were to write that as a logarithm, log base 2 equals the exponent of 0. So another way to take a look at this is, what exponent of 2 gives me a 1? 0. 2 to the what equals 1? 0. All right? So take a look here. 3 to the 0 is 1. So how can I write that as a logarithm? Log base 3 of equals, yay! So b to the 0 is 1. So log base b of 1 equals 0. And that's a property. That's a property that, you all just came up with on your own. Okay? So what about exponents of 1? What's 2 to the 1?
2.
2. So here is the base. Here is the exponent. So I can write it as log base 2 of what? Log base 2 of 2 equal to 1. So what I'm asking is, this is the base, this is the exponent. 2 to the power of what gives me a 2? It's a 1. Okay? So 3 to the 1 is 3. So this will be log base 3 of 3 is equal to 1. So what would be the logarithm version of this? Right. So these we need to know by heart, but now we know why they are the way they are. Okay? Because if you have a base, what should be the exponent so you get the same thing back? A 1. Okay? That's what it is. Okay. Now, these two are what we just came up with. The other two, for the time being, I'm just going to have you memorize, right? So if you have this pattern, log base b, b to the x, it's just x. So for example, if I have log base 4, 4 to the x, if these two are the same, it's just x. Okay? I don't like to use the term they cancel because they technically don't, but it's the pattern. Okay? If you want to go deeper into it, come to me, we will. Okay? Another one is this one. B to the log b of x is x. So for example, if you have 3 to the power of log base 3 of x, so if these are the same, then it's just x. Okay? They don't cancel. I don't like to, be caught saying that, but like they kind of go away and you have that. Okay? Because of like an inverse property. Okay? Again, if you want to go deeper, come tell me. I don't want, it's not worth going into like the theory behind it. Let's do some practice. Okay. We're looking to the answers of these. What is a logarithm? An exponent. So when you're doing these, what are you looking for? An exponent. What's the base? 2. So what should be the exponent of 2 so you get a 16? 4. So it's just 4. That's all. No work shown, but this is a non-calculator question on a quiz or a test, right? Because you can't just plug it in the calculator. We need to know that you know. Okay? So having said that, the numbers are not going to be like 5,234. Like no one knows, those exponents, right? They should be like things that you normally know. Okay? Yep, thanks. So this one. You have log base 5, 1 over 125. So here's how I do this. What should be the exponent of 5 to get you 125? 3. Now, Okay, because you're going from a whole number to a fraction, you add a negative here. Why? Because 5 to the negative 3 is 1 over 125. Okay? Now, for ones like this, when you have a root, always write roots as rational exponents. So, this will be log base 3, 3 to the 1/2. Okay? I just rewrote the root 3 as 3 to the 1/2. So now look at this pattern. What happens if you have log base base? Goes away and you just have 1/2. And that's totally something you can do without a calculator, no? Wait, Sophie.
How is it 1/2 or 2
So the square root of 3 can be written as 3 to the 1/2. Okay? So that's a property of exponents. So if you have, let's say, 3 to the 1/3, or let's make it a different number. If you have 5 to the 1/3, is that cube root of 5? Yeah? And now you can also go backwards. So if you have, for example, the square root of 5, there is a hidden 2 here. So this 5 goes here to the power of 1 over this number is a 2. Okay? Again, if you're weak on that stuff, come to me at bonus. Happy to go over that stuff. Okay, here, this is one that might not be as obvious, but again, on a test, you'll have things that you know. What should be the exponent of 8 to give you 512? 3. Okay, what do you think about this next one? Look at this pattern. B log B is just 15.5. That's it. That's the pattern. So here, we're going to rewrite this like that. How much? 7 to the 1/3. Okay. Now we have a little bit of a problem. Okay? The problem is this number, the base, and this base are not the same. So I need to make those the same base. But man, 7 and 49 are so close, right? Like they're connected, yeah? So let's see what we can do here. This is log base 49. How can I rewrite the 7 using a 49? Square root of 49 is 7, right? Is 7. How can I write the 49 in this form? 49 to the half, right? So why don't we write that as 49 to the half to the power of 1/3? Okay. Okay. So this was like algebra 2, algebra 2, algebra 2, pre-calculus, right? Okay. So look though. Log 49, 49, we can ignore that. We get a half times a third. 1/6. Okay. So we get this. A half times a third, a sixth. Okay. We're going to keep doing that, but we're going to keep doing that. That's it. That's the answer. We're done. Okay? So, all right, a little more.
Wait, what was it?
1/6. Okay, now, common logarithms. Logarithms show up a lot, okay? And again, a logarithm, each logarithm has a specific base. We have, a base of 8, a base of 2, a base of 5, right? And each of those are bases to a power, right? So like this is 5 to the 4. I'm sorry, 2 to the 4, 5 to the 3, and so on. A very common power are when you have 10 to the power of stuff, right? How often have you seen times 10 to the power of? All the time. chemistry, the Richter scale, right? Like decibels, like sound, like everything is 10 to the power. It's so common, right, that when you have a base of 10 in a logarithm, guess what they're called? A common logarithm. Okay? Because mathematicians, they're creative when they come to these names, right? So when they have something that happens, it's very common, they'll just call it a common blah. So this is a common logarithm. A common logarithm is a basic logarithm with a base of 10. It's so common, you don't even have to write it. So if your answer is 1 times x, do you write the 1? No. Same way, if you have log base 10 of 3, you just write log of 3. So if you see a log with no base, no one forgot to put the base there. What was it? A 10. So in this case, I'm yelling because I'm so excited. If the base is a 10, right? What should be the exponent of the 10 so we get a 1? 0. That's why log of 1 is 0. Okay? What's the base here? 10. What should be the base of that 10 so we get a 10? 1. That's why log of 10 is 1. Okay. Suppose there was a base here of 10. Now you get log 10, 10x, and we know with the same pattern that it's an x. But also, look, what should be the base of that 10 so you get 10 to the x? I'm sorry, what should be the exponent of that 10 so it looks like 10 to the x? X. That's why it's x. Like, it's not a secret. I just want you guys to have like some practice with it before I tell you. Now, all you need to know is the pattern. That's all you need to know. Log 10 to the x is x. This one is 10 log 10 of x is x. So let's do some examples. What's the base of this first one? 10. What should be the exponent so I get 10,000? 4. Okay? 4, right. 10 to the 4 is 10,000. It is the same as the number of zeros. Because 10 to the 1 is 10, 10 to the 2 is 100, 10 to the 3, okay? What's b going to be? 12. Because it's the pattern. 10 log 10 goes away. Okay. Now, I'm going to ignore c for a minute. What's the base of d? 10. Now let me ask you a question. What exponent of this will give you a negative 12? So a fraction, no, a fraction will give you a root. There is no way you can raise this to an exponent and get a negative number, because 10 to the 2 is positive. 10 to the negative 1 is 1 over 10. 10 to the 0 is 1. So this is no solution because of this negative. This one, we're going to come back to it because it's the simplest one of all. Now, we talked about common logarithms because when you have a base of 10, it's just so common, right? So you can have like a 10 to the number, you can have 5 to a number, but perhaps the most like zen of powers is when you have a base of e. That's when everything falls into place. E to the x, e cubed, e to the blah, that is like powers in their natural state. And that's why those are called, that's the natural base, and logarithms with a base of e are called natural logarithms. So look, if I have, if I have log, look, Cooper, look. If I have, I know, but you're stealing my thunder. Yeah. So if I have log 10 of x, that's log of x, right? if I have log base e of x, that's ln of x. Okay? So, ln is nothing mysterious. It's just log base e. ln is natural logarithm, but the reason why the letters are switched is because it's in the French version, and then in the French version it's logarithm naturel, so it's ln. Logarithm naturel. It's the same thing, but with a French accent. Yeah? Okay. So, I see an ln walking down the street. What's the base? What is it? What's the base? E. Base is e. What should be the exponent of e so I get a 1?
0.
0. That's why ln of 1 is 0. Okay?
We have to memorize all of these.
Yeah, but you're not remember. Listen, we're gonna do so many you're gonna remember. Okay? But yes, you do have to have them memorized.
So many.
Cause, yeah. Okay, Misha, that's for later. Yeah.
Yeah.
Okay. Base of e. What should be the exponent so you get an e?
1.
1.
Oh, I thought it was
No, we're talking about this one. What should be the exponent so you get an e? A 1. So ln of e is always 1.
Wait. So L N of E to the 1.
So if you have ln of e, is what I'm saying, right? What's the base here? E. Okay. What should be the exponent of that blue e so you get an e?
1.
A 1, right?
L N of E to the E.
Right. Okay. So, and then these properties are the same as what we had before. Okay? So, what should we get here?
4.5.
Yes?
Agreed.
Is that right?
Yeah.
Yeah? Because it's ln e to the e, yep, just 4.5. Whenever you see ln and e together, they kind of make each other go away. They're inverses of each other. Okay? Okay. What's ln of negative 2? What is it? No solution. What's e to the ln of 4? Okay, now, ln of 7, you have to do on a calculator. And also the one we skipped here, you have to do on a calculator. Okay, so those are the only two of all of the stuff we did today that will be on a calculator section. So, you can go ahead and take out your calculators, please, and just plug them. Okay, so listen.
Jeremy, we can do this later, Jeremy. We can do this later.
Okay, we good?
No, yeah, we're good.
Okay. So, I just, listen, I'm not feeling as well as I was, and I don't want to, and I've been yelling too, so I want to not say things a couple times. With these, convention is we go to 3 decimal places, okay? On the test and the quiz, I'll probably tell you, but know that the convention is to go to 3 decimal places, right? So it's 1.146. And listen, we should all get the same answer here because there is no variation. So, if you have a rounding error here, if you did like 5 versus 6 or whatever, that will not be full credit, right? Because at this stage, we all know how to round, yeah? Okay, so, and there is no rounding error for these. Okay, for this one, it's an ln, and again, it's control ln of 7. And, okay, so it's 1.946. Okay? All right. So that's where we're going to stop today. Tomorrow we're gonna learn about graphing logarithms, but this is where we're gonna stop today. Now, the homework is a handout. If I'll give you guys a copy right now, and if you lose it, it's on MyJack. The majority of it should be done without a calculator, and there are only a few that you're gonna do with a calculator. Now,